Good morning, good evening, or good afternoon, depending on where you are joining us from today. We would like to welcome you to today's session of the Azure webinar series. Our topic today is Introduction to Cosmos DB. Before we get started, I would like to go over a little bit of housekeeping. We do have subject matter experts with us today who will be answering questions in real time. So please pop up any questions you might have into the Q&A window and we will get to them as quickly as we can. Also, on the bottom left hand corner of your console, you will find a resources area. Any links mentioned in this session will be easily accessible for you there. Right below the resources widget, you will find a survey. Please provide any feedback you have around today's sessions. Finally, this presentation is recorded and you will receive a copy of this presentation in your email within 48 hours. With that, let's get started. Hello everyone, welcome to the another series of Azure webinar and thank you for your interest. My name is Shrikant Sridhar. I am a technical specialist for Cosmos DB and I'm part of the Azure Global Black Belt team. So this is going to be a three-part event on Cosmos DB, and today in the first part I will walk you through the introduction to Cosmos DB and its features and benefits. And this time I have joined forces with a team of experts, Saranya and Manish, who will be covering some exciting deep dive sessions and demos on Cosmos DB in the next upcoming sessions. Before we jump into the session, I want you to remind you that you can post your questions in the Q&A chat window provided here, and our technical experts will answer to your queries anytime throughout the session. And also, there is a resource widget where you can find the relevant resources on Cosmos DB where you can learn at your own pace. Once again, thank you for registering to this online event, and let's get started with today's agenda. So in today's agenda, we are going to focus on introduction to NoSQL databases, history of Cosmos DB, and reasons why customers use Cosmos DB, and some of the top use cases for Cosmos DB, and who are the top customers they are using Cosmos DB, and the exciting features and benefits of Cosmos DB, a little bit on resource modeling, and understanding the most important topic, request units, and what are the available billing options in Cosmos DB, and what are the different API supports for Cosmos DB, and some of the useful resources for your reference. Let's go. So in the early 80s and 90s, the relational databases ruled the industry. So we all know it stored the data in rows and column format. So SQL databases are really good at what they do and have endured decades of enterprise use, but they have some challenges. If you see, the SQL databases doesn't work well in a distributed ecosystem, and it required high maintenance. So there should be an DB administrator to maintain the database, and it doesn't scale out. So any kind of spike in the workload, SQL databases, it's very to handle it. And there are some schema limitations and relations to your data types, and it doesn't support high volume of data ingestion and variety of data ingestions and velocity of data ingestions. So in the early 2000s, the internet happened. Same time, lots of organizations wanted to take advantage of the internet economics. Over the period of 10 years, the industry focus slowly shifted towards distributed systems, and the necessity of data storage and retrieval required new storage systems. Not only SQL came into picture. So NoSQL databases came to address the problems whatever the relational databases not able to solve. It's highly non-relational and it can scale out based on any kind of workload, and it's schema-less, so you can ingest any kind of data. And let's see a little bit of history of about Cosmos DB. So what is Cosmos DB? So Cosmos DB is a multimodal database service, and it's a answer to the NoSQL database industry for the other competitors. So how it started? In the early 2010, Microsoft started this project as a Project Florence. Basically, Microsoft wanted a distributed database service for its internal large-scale applications. So that's where actually they started this project called Project Florence. And later in 2015, Microsoft released this Project Florence as a document database to the Azure developers, Azure community, and later reiterated with some of based on the inputs and suggestions from the Azure developers, and extended it features to other APIs in 2017. And after that, in 2018, Microsoft released this product as a globally distributed multimodal service with a high availability of 5 nines to the industry. So why we need NoSQL databases and why we need product like Cosmos DB for your applications? If you know, the modern life is app centric. So if you want to stay competitive in the market, any company, either it's enterprise or medium scale or startups, you need to be smart enough to innovate your app or modernize your app, and then only you can sustain and stay competitive in the market. To modernize the app, you need to innovate your app and work on the data in a many different ways. We know the apps runs on data, so there are lots of data that is being gathered from different data sources at this point of time, and we need to innovate how we can actually showcase the data in a more precise way to the customer, to attract the customers to stay competitive in the market. And at the same time, developers who is working on the application and data, they need a new set of tools and and NoSQL databases to leverage the data. So here you go. We have Cosmos DB. It is a one-stop solution to modernize and innovate your app. And why is it so? Because it can handle high volumes of data, and it can gather the data from the different sources, and it is schema-less, and you can actually manage different types of data. At the pretty high level, what Cosmos DB can offer to you, guaranteed speed at any scale, and it simplifies your app development. Your developers will have a lesser learning journey to learn the APIs and make utilize of the data from the Cosmos DB, and it's highly mission critical ready, uh, because you don't need anyone to manage your database, and it can actually scale out and scale down based on the workloads, and it's a fully managed platform as a service, and there are several cost factors you can actually make use of and make it cost effective. So let's move on and deep dive into Azure Cosmos DB and see what are the core benefits and features and API supports in the next available next slides. So as you can see, Azure Cosmos DB, a globally distributed, massively scalable and multimodal database service from Microsoft. And there are different API supports available in Cosmos DB. So you can utilize Cosmos DB as a key value pair engine, or and you can actually port your MongoDB databases workload to Cosmos DB, and you can actually migrate your Cassandra workloads to Cosmos DB and still access the data using Cassandra API. So these are the supported APIs, not limited to in Cosmos DB. And apart from that, it offers you turnkey global distribution. So with a click of a button, you can distribute your workloads across any part of the world. And it's highly elastic in scaling out your workload, either in storage and throughput. So if you have a spiky workloads, you don't need to worry about increasing the RAM or increasing the storage. So it's a fully managed platform as a service. It can actually scale out based on the storage and throughput requirement for your workloads. And as a product, it guarantees you a low latency of less than 10 milliseconds, irrespective of other the scale out options. And for developers, it offers, there are 5 well-defined consistency models you can choose from. So if you see any other products available in the market at this point of time, so either it will provide a strong consistency or a eventual consistency, but Cosmos DB is one of the unique product, provides you, there are 3 intermediate consistency level in between strong and eventual you can choose from, and it backs up with comprehensive SLAs. So let's move on to see why customers use Azure Cosmos DB. These are the top reasons why customer use Cosmos DB. So Cosmos DB, this is the first and only database with a global distribution turnkey capability. So you no need to do manual operations to share your data, distribute your workload across the regions. So with a click of a button, you select the regions, you can actually distribute your workload across many regions. And it is highly big data ready for any kind of workload. So massive scale out on storage and massive scale out on throughput is highly possible. And as I said, it offers you 10 milliseconds of latency for any kind of workload, and it natively support different APIs and data format at scale. And there are 5 well-defined consistency models you can choose from. And it provides you enterprise grade security, and it's naturally analytics ready. Cosmos DB as a product within the Azure ecosystem, it is connected to different product ecosystem where you can actually link Synapse on top of it for any kind of analytical workload. So let's move on to see what are top use cases for Cosmos DB. So these are the top use cases, but not limited for Cosmos DB. I picked up, there are 4 top use cases out of the other use cases. The first one is IoT. IoT is a pretty booming industry right now, and the real-time telemetry data from any kind of device, ingesting lots of data to the system at the same time, reading the data for any kind of quick analysis on top of the data is highly required. If you see what are the top customers, they are using Cosmos DB in IoT scenarios, Mercedes-Benz and ExxonMobil, top-notch customers using Cosmos DB for these kind of scenarios. So why they use scenarios? I can say predictive analytics, predictive maintenance, and finding remaining useful life of any kind of devices, and quick analysis on top of any kind of data. And the next thing is real-time recommendation engines in the retail industry. So what are the top-notch customers? ASOS and Siemens. So what is the use case? Cosmos DB can be used with a lower latency for a high level of recommendation suggestions to the customers. Either it is online recommendations to the user or offline recommendations to the users. It's highly possible. And third is the distributed applications across the world. Say for example, e-commerce is one of the industry where you need geo replication, at the same time high availability and low level of latency. So what are the top customers in the e-commerce industry? So e-commerce giant Walmart is one of the top customer using Cosmos DB. They have different kind of workloads moved to Cosmos DB. Not only NoSQL workloads, even there are some of the workloads from their legacy Oracle system they migrated to Cosmos DB and greatly benefiting out of it. And the last but not the least, a typical NoSQL migration. So what you have, any kind of workloads, what you're running on MongoDB or Cassandra DB, CouchDB, or even HBase, you can actually migrate your workloads to Cosmos DB at the same time, get the benefits of what Cosmos DB offers to you. Yeah, let's move on to cherry pick some of the use case scenarios from these top use cases and see how customers are benefited out of Cosmos DB. At the same time, what is a typical use case architecture for those scenarios. So these are the 3 picked up use cases: IoT use case, and personalization and recommendation for retail, and global mission critical use case. So first we'll move on to the IoT use case. As I said earlier, one of the top-notch customer, Mercedes-Benz, they actually adopted Cosmos DB for one of the cloud-native IoT solution. So what they are looking at Cosmos DB, it's a geo redundancy because they have customers around the world and showrooms around the world, and they want a geo redundancy, high availability, and low latency. So let's see what our customer says. A customer says like how Cosmos DB reduced the development process, at the same time how seamlessly it reduced their software updates and patches to the vehicle user interfaces. Let's move on to see the typical architecture for this Mercedes-Benz use case and how Cosmos DB helped them to scale up. So if you see here, there are lots of device telemetry being ingested to Cosmos DB, and at the same time it is used as a hard path storage, meaning the data will be stored for 30 days, and these data will be immediately available to the user facing apps for any kind of and updates to the users. At the same time, so once the data is beyond 90 days, it will be moved to the cold path, the Synapse link, and actually it will be exposed to Power BI for any kind of further analysis on the data. So let's move on to the second use case, ASOS, the real-time product recommendation engine for the retail industry. So what is the customer looking at in the NoSQL product? So what Cosmos DB offered them, so less than 10 milliseconds of latency for both reads and writes, even for multi-region writes, and global data distribution and elastic scalability because of high amount of data ingestion and change feed for order workflows. There is change feed is one of the important feature in Cosmos DB. You can actually do a lot of things. And let's see what ASOS, the customer, says about Cosmos DB. So they chose Azure Cosmos DB because of its global distribution capability and the ability to handle heavy seasonal bursts, because it is a retail industry and where actually they expected lots of spikes in the workload during the holiday season. So they wanted a solution that can handle a heavy burst of workload during the season without any interruption. So that's where actually Cosmos DB served their purpose. So let's move on to the architecture. So if we see here, from their user interface, the data will be fed to the Cosmos DB. It is again used as a hard path because the hard path will provide the immediate recommendation suggestions to the customers based on their preferences and choices. At the same time, the data will be actually moved to the cold path, and it will be used for offline recommendation whenever during the off season. So let's move on to the another customer, Coca-Cola, because they have business units across almost any country in the world, and what they looking in Cosmos DB. So they wanted a solution that supports global data distribution, at the same time ingestion of petabytes of data. It's not even terabytes of data, it's petabytes of data. At the same time, scaling out the throughput without any intervention. At the same time, enterprise grade service and support. So let's see what our biggest customer Coca-Cola says about Cosmos DB. So being to scale and have insights that are actually delivered. So their primary use case to have a solution that can scale up for any kind of workload, at the same time have the capability to produce the insights whenever the data is moved to the Cosmos DB solutions. This is what actually they want to have. So Cosmos DB served their purpose, handling any kind of petabytes of data, at the same time providing the insights within minutes across the world. So let's move on to see about the architecture. And if you see the data from the different distribution centers and business centers across the world written into Cosmos DB. At the same time, the Cosmos DB data will be used for analysis for their internal operations. So these are the, pretty top-notch customers, and what they feel about Cosmos DB, and what they wanted from Cosmos DB, and how they got benefited out of Cosmos DB. So you can actually get the same amount of benefit in any of the use cases in your organizations, either it's an enterprise or a medium or a startup. So definitely Cosmos DB is a way to go for any kind of NoSQL workloads. So let's move on and see what are the top-notch features and benefits, or exciting features and benefits of Cosmos DB. So as I said earlier, Cosmos DB as a NoSQL platform as a service, it guarantees you any speed at any scale. So it's not like you want to configure any kind of RAM or hardware structures based on your workload. The only thing what you want to configure is what is amount of throughput and latency you need from the system. The system will seamlessly provide it for you. So that's the pretty good feature about Cosmos DB. At the same time, so it offers you lots of open API support and SDK support, and there are SDKs available for Java, Python, and Node.js, and even for .NET. And there are open API support available for MongoDB, Cassandra, and Table API and SQL API. So you can actually fully leverage these capabilities, and your developers will have a very lesser learning curve to onboard their applications to Cosmos DB. And it is highly mission critical ready. It guarantees business continuity at the same time with a high availability and geo replication and enterprise level security for your application. And it's a fully managed platform as a service, and with a different set of billing options, you can actually reduce your total cost of ownership for your workloads. So let's deep dive into some of the features and see what Cosmos DB can offer to you. So as I said, with a click of a button, you can actually distribute your application to any part in the world, and uh, it supports automatic failover. So if there are any outages in any of the region, automatically your secondary region will be made as a failover region without any downtime to your applications. So you can simplify your application development. As I said earlier, there are lots of open API support. At the same time, SDK support available for different languages. So your developer will have seamless transition to use Cosmos DB. And it's mission critical ready with a high availability of 5 nines. And as I said, it has a zero downtime of zero RPO, with a lesser RTO for your application, and it supports all the role-based access to your data to keep your data safe. So it is a fully managed service. At the same time, it is cost effective. There are lots of different options for you to configure the throughput and reduce your billing for your workloads in Cosmos DB. So these are the exciting features about Cosmos DB. Let's move on to see some of the internal operations of Cosmos DB and some of the other topics on Cosmos DB. So how you can visualize Cosmos DB when you, moving your workload from different NoSQL databases. So if you see Cosmos DB resource model starts from a database account, and the database account can have a number of databases under it when you create it. And under the databases, you can actually create number of containers or collections. And so there are several container level scopes available within Cosmos DB. The store procedures, user defined functions, triggers, or any kind of conflicts, all available under the containers or collections you create. So the containers actually how you can visualize, either you can visualize as a collection or a table or a graph based on the API you choose. So if it is a Gremlin API, you consider your container as a graph. And if it is a table storage, you can consider your container as a table. And if it is a document storage, you can consider your container as a collection. So under the collection, you store all your items, that is your JSON documents, and based on the API you choose, you can actually consider what is a document and what is the relevant thing to call based on the API you choose. So this is how you can create your new account of Cosmos DB within the Azure portal, where you can choose different set of options while creating the Azure Cosmos DB account. What kind of API you need, and what is the geo redundancy policy you want to choose, whether you want to choose different regions. At the same time, whether you want to write your data in a single region or multiple region, and how the costing differs for the different region. At the same time, understanding what is the minimum RUs that is required for the container or a database. So anyhow, we are going to talk about RUs in the upcoming slides. At the same time, choosing your workload, whether you want to go for with a production workload or a non-production workload. So I will log into my Azure portal. So once we have the Azure portal account set up, go to the home page and click on the create a resource, and click on Azure Cosmos DB. Yep. So in the landing page, select your subscription and select a resource group, or you can create a new resource group here, or if you already created a resource group, choose a resource group. I already created a resource group for the demo, and enter the account name. The account name should be a unique one. So I created a unique account name, and you can choose what are the API you are going to develop. So for any kind of new application that is being developed from scratch, the recommended way to go is choosing the Core SQL API. And if you have any workloads that you are migrating from MongoDB or Cassandra, you can choose the relevant API support for Mongo or Cassandra. And if you are migrating your workload from Azure Table, so you can choose the Table API. And if you want your Cosmos DB as a graph database, you can choose the Gremlin API. So I'm choosing the Core SQL API now, and you can choose the location nearest to you. Okay, I'm choosing the Southeast Asia, and the provision throughput. And so these are the free tier discount. You can actually have more information when I share how you can try Cosmos DB. And you can choose whether it's a production workload or a non-production workload, and geo redundancy. So if you can enable and see what are the different regions you can choose, and multi-region writes, whether you want your workload to be written in the multiple region, and availability zone, whether you can enable or disable here, and you can just review and create. So it will take some time to uh, uh, so do the validation. After the validation is complete, just create. So it will take some time to create your newly created database account. So you can actually look for the progress in the progress bar here. So let's move on to the session. So let's see how to create a container under the database account. So once you completed creating your database account in the Azure portal, the next step is to create the databases and the containers under it. So you can see this set of features while creating the container, and so you can choose the existing database ID, or you can create a new database ID, and you need to provide the container ID. At the same time, there are three key aspects you need to understand: the request units, where you need to configure your throughput. At the same time, the partition key, that is one of the key important topic, and the data modeling. So let's move on to the demo and see how we can actually create a container.
So let's see how to create a container within the database what we created earlier. Once you log into the Azure portal, in the home page, look for the database account what you created earlier. Click on the database account and click on the add container. So here you can choose any existing database ID whichever you created earlier, and if not, you can create a new database ID. So since this is a new database account, I'm creating a new database ID. And this is where you can configure your throughput for this particular database either by a manual mode. So the minimum requirement of throughput for the database is 400 RUs. So you can actually choose the manual mode here and select the number of RUs. And if you're not sure about your workload predictability, you can go for auto scale. So if you see here, the auto scale, you can configure a number of RUs here. At the same time, your RUs will be managed by Cosmos DB. The lowest it can go is 10% of maximum whatever you are configuring here. And you can see, what would be the estimated billing if you configure the different RUs here. So if you go with manual mode, what would be the pricing for monthly, and if you go for auto scale mode, what would be the pricing for monthly billing. So let's select manual, and let's choose a container. So partition key is one of the key factor in Cosmos DB. While creating your container, you need to provide the partition key to distribute your workload properly within Cosmos DB. So once you create the partition key while creating the container, you cannot change the partition key once it is created. So analyze your workload and look for the top performing queries or your insertion pattern, and understand what would be the right partition key before creating the container. So it can be an unique ID. The more number of unique values or the more number of cardinality, your data will be distributed accordingly in Cosmos DB. So for time being, I'm giving ID as my partition key. An analytical store is one of the feature available in Cosmos DB. So it will be an extended feature for doing some analysis on Cosmos DB. So if you switch on the analytical feature here, your transaction store will be stored in a columnar way. So it will be available for faster access for any kind of analysis in your data in Cosmos DB. So I have given whatever the key parameters required to create my container. So if we see here, our new container has been created with whatever the properties we wanted. If you want to see what are the settings you configured for the container, you can go to the settings and view the default configurations. So whatever the partition key I have chosen, so it is available here, and you can change the indexing policy here. So by default, for the SQL API, all the properties will be indexed in Cosmos DB. So you can actually include or exclude any of the properties to be indexed from here.
Just now we've seen how to create a container, and let's focus on the request units in the coming slides. So what are request units? So request units is a unique way of configuring throughput. At the same time, it is a very key factor for your billing in Cosmos DB. So it's not something like similar to other databases services available in the market. So request units in Cosmos DB, it's a rate-based currency. So as I said earlier, you don't need to configure any of the memory, RAM, or storage required for your operations what you do in Cosmos DB. So the only thing what you focus is the amount of storage what you are storing in Cosmos DB, and the second thing is the amount of throughput what you are expecting for your workload. So request units is a physical abstraction of how the platform as a service offers you the memory and the hardware for providing your throughput for your workload. So understand better about request units. To read a 1 KB of a JSON document from a Cosmos DB, it will require one request unit. At the same time, when you want to write a 1 KB of document to Cosmos DB, it will require 5 request units. So each request, either it's a write or read or upsert or delete, will consume fixed request units in Cosmos DB. The request units can be affected by several factors, either the size of the document or the indexing of your document in Cosmos DB. So all the other background operations in Cosmos DB doesn't impact your request unit consumptions. So why request unit is important to understand? Because it is going to be a key factor in deciding your billing for your workload. So let's move on to see how the billing model works in Cosmos DB. So if you see, there are two components in the billing factor of Cosmos DB. So the billing is a combination of both the amount of storage you store in Cosmos DB and the amount of throughput you provision in Cosmos DB. So if you see, if your workload is somewhere around 50 GB and 50 GB multiplied by 0.25 dollar per month, that is going to be added as part of the billing, and what is the amount of throughput you provision at the same time multiplied by number of provision throughput multiplied by 0.008 dollar per hour, that is going to be your RUs. So combination of both storage and the provision throughput RUs per hour will be your billing. So if you are configuring your Cosmos DB workload in a multi-region RAID, so the billing will be 50% higher than a single region RAID. So let's see how we can actually estimate the RUs for your workload. Say for example, you have you are writing a single document, and the request per second is 10,000. Say for example, the RUs consumed for writing your document, it's 10 RUs. So it is 10 multiplied by 10,000 will be 100k RUs required for your writing a single document to Cosmos DB. And you can actually analyze your topmost queries and see what are the highly accessed queries from Cosmos DB. Say for example, one of your top query, you are performing for 700 queries per second, and it is costing you 100 RUs. So it is multiplied by the particular value will provide you the guesstimated number of RUs. So the same way you can actually go through the top queries what you perform and top operations what you perform in Cosmos DB, and you can actually guesstimate your RUs what is required for your workload. So let's see how we can actually configure RUs in Cosmos DB. So as I shown in the demo, you can actually either configure RUs in a auto scale mode or a manual mode. So the manual mode, so you can actually configure what are the number of RUs for your workload. So it is good for predictable workloads. If you know, your workload is very predictable, and you can actually configure your RUs in a manual mode, so that actually you know what is the billing going to be at the end of every month. And if you're not aware of your your workload, if it is highly unpredictable, so you see spikes in your data, then you can go for autopilot mode, where you can actually configure between 10% of the maximum value what you are provisioning here. Say for example, if you're provisioning 4,000 RUs here, the minimum RUs will be 400 RUs required for that particular container. And this provisioning you can actually initially try with your workload and understand your patterns and see what is the best way to go choose between these two options. And there are more details about what are the scenarios you can choose the autopilot mode or auto scale mode and manual provision. And if you see, so auto scale has several advantages, like it is very simple. So you can actually configure auto scale mode, and the Cosmos DB platform will handle your spikes in the workload, and it is highly reliable. And there are no rate limiting operations in auto scale mode. So any kind of spikes will be seamlessly handled by your auto scale mode. And the price slightly differs for the auto scale mode, and if you see here, the cost for the provision RUs is 50% higher. At the same time, the RUs can be configured at the database level or at the container level. Let's see how we can do that. If you see here, as I shown in the hierarchy, Cosmos DB starts with an account, and there are number of databases available below that, and the databases will have number of containers. So you can provision your RUs at the database level. If you provision your RUs here at the database level, all your containers under your databases will equally share your provisioned RUs based on the database. So why database level throughput is good for some cases? because throughput is shared among each container, and you don't need to provision dedicated throughput for your containers. And let's see how we can actually provision RUs at the container level. So if you don't want to configure RUs at the database level, you can anyhow choose provisioning individual RUs for individual containers. If you are not aware of how much the container going to be impacted with your read write queries, you can anyway, go and configure your RUs at the container level. So whatever you did, the auto scale or manual mode, you can choose the same option at the container level. So individual containers will have its own RUs without disturbing or impacting other RUs. So you will have a more dedicated throughput for your container. So what are the differences? What are the cases actually you can choose database level throughput? In general, container level throughput is a good choice. So this leads to predictable performance since actually we know each container has its own guaranteed throughput. And if you want to choose database level throughput, and what are the cases you can choose? If you are lifting and shifting some of the migration from any of the workloads, right? And you don't know how much throughput you want to configure for each container under it. So you can anyhow go for a database level throughput. So you can monitor the usage for some time, then actually you can decide for the whether to go with the container level or a database level. And there is a mixed option available. So in some of the workloads, you can see this pattern too. So there will be some RUs configured at the database level. At the same time, there will be some containers will be accessed more, and it will require a dedicated throughput. So you can actually specifically modify that throughput for the particular container. This is a mixed model. So let's see on the example on how the billing works here. So as I said, it's a combination of storage what you have in Cosmos DB, at the same time number of throughputs what you are performing in Cosmos DB. So it's a combination of both the storage and the number of throughput you configured. And if you see here, the storage cost and the throughput cost, and together it's a guesstimated value of monthly billing for your workload. There is a new addition in the configuring your RUs in Cosmos DB. It's called serverless. It is in preview mode now. So what is the use case? It is for non-critical applications. When you have any kind of workloads that is running on your serverless mode, you can configure Cosmos DB, and you can actually write or read to Cosmos DB from the serverless APIs. And there are several limitations since it is for very low level of workloads. So the maximum throughput that is supported is 5000 RUs per second, and the maximum storage that is supported is 20 GB. So let's move on how we can actually identify the RUs that is required for your workload. As I said, analyze your workload, whether it's a read heavy or write heavy system. And for a read heavy system, you analyze your top queries and see what are the queries you are going to perform, and decide what would be the RUs that is required for your workload. And at the same time, what are the number of items that is going to be indexed from your JSON document, that is also going to impact your RUs. So be mindful and see what are the items you want to index in your JSON document. So these are the three ways actually you can arrive at a proper guesstimation of RUs required for your workload. I think we covered enough on the RUs. Let's move on to see the API support and benefits on Cosmos DB. So as I said earlier, Cosmos DB, it is mostly suited for any kind of NoSQL database migrations. If you see here on the left side, if you are having any workload from Cassandra, MongoDB, or DynamoDB, or Neo4j or HBase, CouchDB, so you can actually still migrate your workload to Cosmos DB at the same time with the NoSQL via protocol, with the open APIs available for it. You can actually modernize and innovate your applications running on these NoSQL workloads. So these are the API support available. SQL API is the core API, and MongoDB API for MongoDB workloads, and Table API for Azure Table Storage, and Graph API for any graph databases, and Cassandra API for Cassandra workloads, and Spark API and etcd. So let's move on to see the core SQL API. So, why the Core SQL API is pretty much important in Cosmos DB? Because, as I said earlier, it is not only the NoSQL use cases we can migrate to Cosmos DB. At the same time, there are several customers like Walmart moved their SQL workloads or legacy applications from Oracle to Cosmos DB. In such case, all the developers maybe they would have been used to writing SQL queries, right? In such cases, they can still use the SQL queries to access their workload from Cosmos DB. In such cases, you can definitely use SQL Core API to access the data from Cosmos DB. So what are some of the features on Cosmos DB for the SQL API? So the elastic scalability, the multi-region replication, and as I said, a familiar SQL syntax, and it is a fully managed servicing, and it supports automatic indexing. So how you can manage your documents from Cosmos DB? So you can actually manage your documents via Azure portal, what I shown now, and you can actually anyhow manage your data from Cosmos DB using the SDKs from any language and REST API, and you can actually use a data migration tool to access your documents too.
So we have seen earlier how to create a new database account in Cosmos DB and how to create a new container with required throughput for your container in Cosmos DB, and followed by in this step we can see how to manage your documents and monitor your Cosmos DB using Azure portal. So once you log into the Azure portal, in the home page, click on the relevant Cosmos DB account you created. So once you landed in the particular overview section, go to the Data Explorer menu. So from here you can see what are the available containers we created under the database, and you can actually view your JSON documents by running a query in the Azure portal. So let's query this database container. Click here and you see a new SQL query tab here. Click on this, and by default there is a query populated. So let me execute this query. So these are my documents stored in the family container of my earlier created database, and from here you can see the query stats, where you can actually see what are the number of RUs that is consumed for executing my particular query. So anyhow, the recommended way is to identify the RUs from the SDK, so that will give you more exact number of RUs that is being consumed for executing the queries to Cosmos DB. And in the same menu, you can actually manage your Cosmos DB. So if you want to replicate your workload to different regions, click on replicate data globally, and here either you want to enable multi-region writes for your workload. If you want multiple region writes for your workload, you can actually enable it and select the region you want to choose and click save. And there is an option for automatic failover here. So once you do that, whenever there is a disaster, whenever your primary region goes down, your the next secondary region will be picked up by default by Cosmos DB as a primary region. So you will have zero downtime in Cosmos DB. And if you want to choose a different consistency level for your API, you can do it from here. So if you go to the default consistency page, you see right now it is chosen for session consistency. So you can choose different consistency level here and save for your workload. And this is the option to configure your backups and restore. So there are certain limits, time limits for your backup to configure. So based on the time limits provided here, you can actually modify these settings for your workload backups. And there are certain ways you can actually monitor your throughput and Cosmos DB. If you go to metrics section here under monitoring, so select on the databases and select on the container, and you can select on the region and see how many RUs that is consumed for the particular database engine, and clicking on the throughput will show you that particular number of RUs. We see here how many number of requests and how many number of RUs that is being consumed for the particular container in the region. So you can actually like monitor any kind of KPIs from here with Cosmos DB.
So how we can actually like import your workload to Cosmos DB? So if we see here in the left side, any kind of NoSQL data or NoSQL data, you can use Azure Data Migration tool to migrate your workloads to Cosmos DB. So let's move on to see some of the benefits of Mongo API and Cassandra API in Cosmos DB. So as I said, Cosmos DB supports Mongo API and Cassandra API for a different set of workloads. So what are the version that is supported for MongoDB API? So if you see here, version 3.2 to 3.6 is what actually supported in Cosmos DB. So if you have any workloads that is running on this kind of MongoDB versions, you can actually port it to Cosmos DB without any hesitations. At the same time, it is highly on the feature to feature comparison instead of version to version comparison in Cosmos DB. So let's highlight some of the key benefits of using Mongo API and in Cosmos DB. So if you port your workload from MongoDB to Cosmos DB, so what are the benefits you are getting in Cosmos DB? So there is no management overhead, and you no need to manage your sharded clusters, what you do in MongoDB, and you don't need to manage your replica sets, and there are no worry about chunk migrations, and you don't need to use the typical tools like MongoTop or MongoStat, what you use in MongoDB in Cosmos DB. So at the pretty high level, so whatever your ecosystem you are using currently in MongoDB, so all the tools and ecosystem can be still used in Cosmos DB. If you see here the import export tools and the data visualization tools like Mongo Shell or Robo 3T, all these tools are actually still usable in Cosmos DB. At the same time, so all the Mongo operations, what you do in MongoDB, so it is still possible in Cosmos DB. So let's move on to the specific benefits about Cassandra API. So if you see here, any kind of workload you are migrating to Cosmos DB, and what are the key benefits of Cassandra API in Cosmos DB? So no management overhead, and no need to manage the tombstone hinted handoffs in Cosmos DB, and you don't need to use any of the node tool or any kind of VM stat, whatever you're using in Cassandra, and don't need to manage or monitor using JVM settings. So since you have Azure Portal and relevant tools in Cosmos DB, your management and Azure metrics will be handful for your any kind of workloads. So still the existing ecosystem, whatever you use in Cassandra API or Cassandra DB, so still it is possible to use in Cosmos DB like SQL Shell or Portal. At the same time, it supports partitioning and TTL, whatever you have in Cassandra API. So let's move on to the graph structures on Graph API. So what are graph structures? So if you want to have your data stored and you want to have the relationship between the data as a nodes and edges, you can actually use Gremlin API to access your data from Cosmos DB. So there is a Apache Gremlin API support for Cosmos DB. And so what are the benefits for Cosmos DB? So it can provide you graph modeling, and you can have traversal APIs in Cosmos DB. At the same time, elastic scale out, automatic indexing, all other features by default come to your Graph API database. So what are the scenarios graph in Cosmos DB? So if you want to use your database as a social network, networking site, or recommendation engines, or logistic, if you want to track any of your moving vehicles from source to destination, and telecommunication, finding the relationship between different towers and different entities, all these workloads falls under this category. I think I covered the exciting benefits about Cosmos DB and its APIs and features. Uh, so this brings us to the end, and but there is more coming in part 2 and part 3. So as I said, our team of experts Saranya and Manish will cover the part 2 and part 3 for you. So if in the part 2 it is more on the demos to demonstrate the millisecond latency and scaling and partitions and showcasing multi-master writes and writing the SQL queries and deep dive on MongoDB API and Gremlin API. And the third session, so we will be more focusing on the bulk ingestion, how we can use bulk ingestion to ingest your data, about Apache Spark, and monitoring your Cosmos DB and deployment strategies and migration strategies. So these are the ways actually you can try out Cosmos DB. So you can try Cosmos DB using Cosmos DB emulator. Is a local downloadable version of Cosmos DB. So you can actually install it in your local machine and still get the benefits of creating an account and using the Cosmos DB in the Azure portal. And there is a Azure Cosmos DB free tier available. So you can actually create an account, and there is a free account given for 400 RUs and 5 GB of storage for initially for you to try out. And there are several resources available here for you to learn from Azure portal. You can actually build your skill on Cosmos DB from Azure portal. So there are several labs available, some GitHub repository available for your learning at your own pace, whether it is a simple lab and scenario-based labs. The scenario-based labs will cover you IoT scenarios and retail-based scenarios. And Microsoft Learn, it is a free service available from Microsoft. You can actually browse through all set of courses and make yourself equipped with sources available in Microsoft. Thank you once again for attending this event. We are open to Q&A now. Just drop your questions in the Q&A box and our experts will answer them shortly. There are 2 more sessions coming up with some exciting demos. Hope to see you there, and thank you.